Today we're going to find or apply the use of the derivative in some calculus problem. And for today we're going to find the tangent line to the curve given a point. So we have several examples right here, and let's go ahead and start with problem number 1. So problem number 1 is a trig function y equal to secant x. So y equals secant x at point pi over 3 and 2, and we need to find the tangent line. So we know to find the tangent line we need the value of x, we need the value of y, and we need the value of the slope. The value of x and y, they are given. We have pi over 3 and 2. We just need to find the value of the slope. And to find the slope, we know that we could just simply find the derivative of the function to find the equation that will help us find the slope of the line. So y prime is simply y ddx of secant x, and the derivative of secant x is secant x tangent x, so y prime is secant x times tangent x. But we're supposed to evaluate it at x equal to pi over 3 so we can find the slope at that point. So we have y prime evaluated at x equal to pi over 3. So we'll have secant pi over 3 times tangent pi over 3. At this point in the game, you need to know the values of your unit circle to be able to find the values that we're looking for. So we have sine, cosine, tangent, and secant is the inverse of cosine. So we'll look at cosine pi over 3, which is 1/2, and get its reciprocal, which is simply 2. So we have 2 right here, multiplied by tangent pi over 3, which is square root of 3. And this is now the value of our derivative evaluated at pi over 3, which is 2 square root of 3, which is also our slope. So now we have our slope, which is 2 square root of 3. Now we're ready to write the equation of our tangent line. So the tangent line can be written using the formula of the point slope form, which is y minus y sub 1 times m equals m times x minus x sub 1. And by substitution, we'll be able to produce the tangent line of this particular function at point xy. So y minus 2 equals 2 square root of 3 x minus pi over 3. And that is the answer for problem number 1. Now let's go ahead and answer problem number 2. On problem number 2, we're supposed to use the function y equals secant x minus 2 cosine x at point pi over 3 and 1. And we need the value of x, y, and m to solve this problem. So x is given, y is also given. We just need to find the slope. And to do that, we're going to take the derivative of this function. So we have y prime is equal to the derivative of secant x minus 2 times the derivative of cosine x. So by the derivative rule, we know that the derivative of secant x is secant x tangent x. So this is simply secant x times tangent x minus 2 times the derivative of cosine x, which is negative sine x. So you need to know your rules very well to be able to differentiate trig functions. Now by simplifying our derivative function, we'll have secant x times tangent x plus 2 sine x. All we need to do now is to substitute the value or to evaluate the derivative at x equal to pi over 3. So we will replace all the x's with pi over 3. So we'll have secant pi over 3 times tangent pi over 3 plus 2 sine pi over 3. And using our values once again, we know that secant pi over 3 is simply cosine pi over 3 and its reciprocal, which is 2, multiplied by tangent pi over 3, which is square root of 3, add it to 2 times sine pi over 3. And sine pi over 3 is square root of 3 over 2. And by simplifying our expression, we can cancel out the 2 right here, and we'll end up with 2 square root of 3 plus square root of 3. And since we can combine these two together because we have the same radicand, so we have 3 square root of 3 for the value of our derivative evaluated at x equal to 3, which we know is our slope as well. So now that we have our slope, which is 3 square root of 3, we are now ready to write the tangent line, which is found using the point slope form. And by substitution, y minus 1 equals 3 square root of 3 times x minus pi over 3 will be our tangent line for problem number 2. And for problem number 3, we have a polynomial, and we're going to simply do what we just did on the other two examples, but this time it's going to be a lot easier because we just need to use the chain rule. We are given a point which is 0 and 1. So we know that x is 0, y is 1, and we need to find m. And using the chain rule, we'll be able to take the derivative of this polynomial. So y prime is simply 10 times 1 plus 2x to the 9th times the derivative of the inside, which is 1 plus 2x. So y prime is equal to 10 times 1 plus 2x to the 9th times 2. So now that we have our derivatives, let's go ahead and evaluate the derivative at x equal to 0. So we'll have 10 times 1 plus 2 times 0 raised to the 9th multiplied by 2. And we'll have 10 times 1 plus 0 to the 9th multiplied by 2. And we'll have 10 times 1 multiplied by 2, which gives us 20. So the slope of our tangent line is at 20. And let's go ahead and write our tangent line because we have our information now to complete the equation given by y minus y sub 1. Substitute. And we'll have the equation of the tangent line. And if you want to further simplify this to become the slope-intercept form, you can just isolate the y using algebra, and you'll have another version of your equation of the line. Now for our last example, we'll find the equation of the tangent line and the normal line of the curve at the given point. So this is the curve, this is the point, and we're only given x equal to 1, and we need to find two equations, the tangent line and the normal line. So just like what we did before, all we need to do is to find the value of x, find the value of y, and find the value of the slope. Now, x is given, y is not given, so to find y, all we need to do is to substitute the value of 1 to our equation. So we have 1 cubed plus 1 all over 2 times 1. So we'll have 1 plus 1 all over 2, which gives us 2 over 2, which is 1. So we have x and y already. Now we just need to find the slope. And to do that, we'll find the derivative of this function. And to find this derivative, we're going to use the quotient rule. And we all know the quotient rule, which is low d high minus high d low over low low. So let's write it down. Low d high minus high d low all over low squared. And by using this formula, low is the denominator and high is the numerator, we'll have y prime. So let's go ahead and find the derivative using the quotient rule. So we'll have low, which is 2x, times the derivative of high, which is x cubed plus 1, minus high, times the derivative of low, all over low squared. And by simplifying it and applying the rules of the derivative, we'll have 2x times 3x squared minus x cubed plus 1 times 2 all over 4x squared. So we know that we have taken this derivative and this derivative right here. That's why we have these functions. So now that we have differentiate our function, all we need to do now is to evaluate this at the value of x. So we have our y prime, and we're going to substitute the value of 1 to this function. So we'll have 2 times 1 multiplied by 3 times 1 squared minus 1 cubed plus 1 times 2 all over 4 times 1 squared, which will give us 2 times 3 minus 2 times 2 all over 4. And by simplifying this, we'll be able to find the value of the slope. So we'll have 6 minus 4 all over 4, which is 2 all over 4, or 1/2. So just like what we did before, we're going to find the value of the tangent line and the value of the normal line. So we know that x is equal to 1. We also know that y is equal to 1. And we also know that m is equal to 1/2. So if we're going to write the tangent line to this curve at point 1, 1, it will simply be y minus y sub 1 equals m times x minus x sub 1. So y minus 1 equals 1/2 times x minus 1. This will be the tangent line. Now we need to find the other line, which is the line that is normal to the curve right here. So the normal line in mathematics is basically the perpendicular line to this particular curve. And we already know the slope, and we know that the relationship between the slope and the line perpendicular to it is the negative reciprocal. So negative reciprocal of m is simply negative 2, because if we have m, its negative reciprocal will be 2, so we can now write our normal line, which is y minus 1 equals negative 2 times x minus 1. So this little piece of information right here is what you need to be able to answer the second part of the question. And this is how we find the equation of the tangent line on a given point.